Hello everyone. So today what we are trying to do is we are trying to solve a previous year problem, KTU previous year problem. This problem is from module 5. It is from stress transformation. Okay. So the problem here, what I am trying to solve was asked in 2017 December. It was asked for 14 marks. The question is, draw Mohr circle for the two-dimensional state of stress shown in figure 2. So this is a figure. Find the principal stresses and their planes. So what we have to find is, we have to find principal stresses, principal planes. Okay. So that's what we have to do now. Okay. So this problem has to be solved using Mohr circle. So in KTU paper, you will not be given a graph paper. What you have to do is you have to draw in your answer sheet booklet only. So you should be able to draw an axis with proper scales. Okay. So I will try to draw an axis here. So let's say this is my sigma axis. I also need a shear axis. So let's say this is my shear axis. Okay. So this is my positive sigma, this is my negative sigma. Now if you observe the values given to us, we have, if I call this as x direction, this is y direction, I have sigma x as 120 minus 120 MPa, minus because it is compressive. Sigma y is again it is minus 80 MPa, and we have shear as 60 MPa. Now actual nature of the shear stress is negative. We will not get into that. It's actually negative 60 MPa. We don't need to know the sign. We will see how we will consider the signs of shear when we draw the Mohr circle. So when we draw the Mohr circle, this axis is sigma axis. So this right hand side is a positive sigma normal stresses, and this is negative normal stresses. Here we have tau axis. So in tau axis, all the clockwise shear has to be drawn in the upper part, and all the anti-clockwise shear has to be drawn in the lower part. Okay, shear we will see what is clockwise, what is anti-clockwise when we solve the problem. Now we have to take up a scale. So it is important that we have scale, same common scale for both x and y. Okay. So I will say the maximum value is 120 is what we need, minus 120. So I will take 1 division as 10 megapascal. So 1 minus 10 minus 20 minus 30 minus 40 minus 50, 60, 70, 80, 90, 100, 110, 120, 130, 140. So I think we may need a little bit more length here. So I'll just draw that also. Minus 150. So we have here 10, 20, 30, 40, 50 and so on. Okay. Then we have shear, again 10, 20, 30, 40, 50, 60. This is 10, 20, 30, 40, 50, 60. Okay. So this represents anti-clockwise direction shear, clockwise direction shear, and this represents anti-clockwise direction shear. Okay. Now we have to find points to draw the circle. So first what we will do, we will find this plane. We will use this plane. Okay. So this plane, if I see, this plane has 120 MPa minus 120 MPa as the normal stress, and this is shear stress of 60 MPa. Okay, and if you see, this shear stress is trying to rotate this element in the clockwise direction, right? So I have minus 120 here, minus 10, 110, 120 here. And since it's clockwise, I have to plot it in this quadrant. Negative in sigma and clockwise is this quadrant. Okay. So 120, so this is 50, this is 60. So this is 1 point. What I have marked is this point is nothing but minus 120, comma 60 clockwise. Now we have to go to the other face. This is the other face. So if you go to the other face, we have a 80 MPa minus 80 MPa as compressive force, compressive stress. Then we have 60 MPa shear stress. Now if you see, this shear stress is trying to rotate in anti-clockwise direction, right? So anti-clockwise and negative we have to draw in this, we have to find the point in this quadrant. So it is minus 80, so 50, 60, 70, 80. So this is 80, minus 80 and minus 60. So this is the point. Okay, I think 50, 60, 70, 80 and 60. So this is nothing but minus 80, comma 60 in the counterclockwise direction. So I have 2 points here. So these 2 points basically represent stresses in 2 planes. So this is a plane which is vertical, this is a plane which is in horizontal direction. Okay. So now what we have to do, we have to draw these 2 points. So let me draw the point with a line. So from here to here I have to draw a point. So I'll try to, right. So this represents the diameter of my Mohr circle. This will be my diameter of the Mohr circle, and this will be the center. So this point will be the center. This will be the center. Now I will try to draw the circle. So what I will do, I will take a compass. I will put the center here. I will rotate it. Wait. I'll rotate it. I will adjust the radius. So I think I am okay. Yeah, I will draw the circle. So this is the Mohr circle. Okay, this should have been passing through this point. Maybe there is slight issue with my sender. Let me see. So I think we can manage this. We are just trying to understand. Okay, slightly better, not perfect, but fine. So this is my Mohr circle. This is Mohr circle, right? This is my Mohr circle. I have the diagonal. I have the radius. Now we have 2 important points here. So this point and this point. These 2 are very key important points. These are what is the these points represent principal stresses. Okay, so I'll call this as sigma 1. I'll call this as sigma 2. Okay, so you can see. So this the peculiarity of this point is circular. This point is the point. These 2 points are the points in which the shear stress is 0. Right? Because these 2 points, which is a part of the circle, lies on the sigma plane, sigma line. So shear stress is 0. So these 2 are principal stresses. So we can see, we can observe from this, sigma 1 is approximately equal to 50. This is 160, something around 165 MPa minus 165 MPa, and sigma 2 is somewhat around this is 10, 20, 30, something around 38 MPa, again minus MPa. Okay, so you have to remember this point is nothing but it represents this plane, horizontal plane. Okay, now with the original planes that we have considered, that means this point and this point corresponding to this plane and this plane, we have to see at what orientation we have the principal plane. Okay, so basically what we are trying to do is we have a square. So this is my blue square. So this is my original, let's say this is my original stress block. Okay, original stress block with all the stresses, 80, 120, have 60. Okay, now the question is, at what orientation do we have the principal plane? So this is our original orientation. Okay, now they're asking at what orientation we have, so we can rotate this plane like this. So at what theta do we have this principal stresses? So if I rotate it at some angle, this was my original angle, so this is my theta. At what theta will I get the principal stress? Either orientation principal stress. Okay, so that rotation will be given by this angle. Okay, this is 2 theta. You have to rotate in counterclockwise direction. The angle you have to rotate is this angle. Original diagonal angle 2 theta. Okay, now we have to measure this angle to find the plane. So let's measure that. So I will take my protractor out. So I have my protractor somewhere here. I have my protractor here. Yes. Now I will put the center here. Okay. Now let me rotate it. Just the size. Right. So what I am seeing is the angle we are measuring is something around 71 degree. Okay. So 2 theta is approximately coming out to be 71 degree. So theta is nothing but 35.5 degree. Okay, so it is in counterclockwise direction. So this, when we have theta is equal to 90 degree. So let me remove the protractor. When theta is counterclockwise, that is 35.5 degree, we get the principal planes. So what is that? From which plane do we get the principal stresses? That we have to see. So originally, you can see from this point 80, 60. So from this plane, so this plane, if you rotate this plane by 35.5 degree, we get sigma 2, that is minus 38. So here we have minus 38. Minus 38. Okay. And also the perpendicular to that 180 degree, that means 90 degree, 2 theta is 180, so 90 degree we have sigma 1, that will be 165. So here we have 165. Okay, and this is principal planes, so there is no shear stress, so shear stress will be 0. So this was original, this plane was rotated by theta, so you can imagine this plane has moved here. When it is moved here, it has become sigma 2. So that is, the stress in that plane has become 38 MPa. I hope it is clear. Okay, so this is how you find, how you solve this problem using Mohr circle. So this is the answer. This is all we have to give. But it is natural to expect checking of these answers. So we will use this analytical method to find the solution. First, what we will see, we will find the radius of the circle. What is the radius of the circle? So radius of the circle is given by sigma x minus sigma y by 2 whole square plus tau xy whole square. So this is there in the Mohr circle derivation. So this comes out to be, so if you see, sigma x is minus 120 plus 80 by 2 whole square plus 60 square whole to the power half. So this comes out to be something around, so give me a moment to work out. So 20 root 10 or 63.24. So this is the radius of the circle. The radius of the circle is nothing but 63.24 MPa. And the center point of the circle, this point, it is generally called the average stress or sigma average. So sigma average can be found by, so where will I write? So I can write here sigma average equal to sigma x plus sigma y by 2. Okay, so that is nothing but minus 120 plus minus 80, so minus 100 by 2 is, so minus 200 by 2 is minus 100 MPa. So you can see this from graph also. From graph also you can find this. It is 100 MPa. It is matching. Okay. So this is how you find the center of the circle. It is sigma average. Now principal stresses we can find sigma 1 equal to sigma average, value of sigma average. So sigma 1 and sigma 2 can be given as sigma average plus minus radius. Okay, sigma average in we can add radius to get this. We can subtract radius to get this. Okay. So this gives me sigma 1 as minus 165 minus 63, sorry, minus 100, I'm sorry, minus 100 minus 63.24, so that is minus 163.24 MPa. So it's very close. We have minus 165 here. The analytical answer is minus 163.24. This is more accurate. So sigma 2 is, so the accuracy issue is because of the circle. We have drawn the circle in approximate graph paper and all. If we are drawn in an actual graph paper with actual scales, with actual divisions, we can measure this. This is minus 100 plus 63.24. Okay. So that comes out to be minus 36.75. So this is correct. This is correct. Correct means approximately both are matching. Okay. Now what about theta? We have to see theta. Theta we can found by this formula. Tan 2 theta p equal to tau xy by sigma x minus sigma y by 2. Okay, so this will give me value of theta p. So if you work out this here also you will get theta p equal to 35 or something, 35 point something you will get as the answer, which is the same answer that we have got. So you can work this out. I'm not working this out, but I hope it is clear, right? So this is how you solve this problem. 14 marks is a very simple problem. Only thing is slightly, slight care should be given. How do you mark the points? Main important things that you have to remember is clockwise shear we will put in the top portion, anti-clockwise we will put in the bottom portion. So there are many ways of drawing this. This is one way of drawing how the shear is considered. There are some other ways also, but I feel this is easier way to follow, so that is why I am using this. Then important thing that you have to remember is both should be in same scale. Scale should be clear. It is better to have same scale in both. Yes, so that's all. I hope you understood the problem. What we will do, we will do another video of another problem which was asked in KTU. Hope it was clear. Thank you.